You will be, Harold, will you be advancing the slides?
Yes, I will do it.
Great. Harold,
Um,
welcome. We're glad to have you here along with your associate, and I'll
yeah,
back out and you can proceed with your presentation. Thank you.
yes, thank you. So, ja, ja, ich versuche es mal, ob ich die Kamera noch mit, aber die zeigt irgendwie ein bisschen. Hm.
Aha!
Doch, okay, okay, gut. Und jetzt noch das Thema halt Sharing. Ja, ich mache es mal jetzt. Hups. Okay, you can see it. Mhm. Ja, kleinen Moment. Sorry. Now? Mhm. Nee. Oh, sorry. Mhm. 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 Ich mache jetzt nochmal hier. Doch, alles teilen, das ist vielleicht besser. Und jetzt, okay. Now? Okay, okay. Thank you very much. Thank you very much also for your introduction. Yes, today I would like to present together with my colleague from Fabmatics, Siegfried Ickert. The title is Automating a Mature Fab Means. And this is really a big question. What does it mean to automate a mature fab? I would like to go a little bit more in details about our learning, our history, how Infineon Dresden has done this. And Siegfried is then more going into the future side of new generation of robotic systems, which we always need then also for the next step of automation in the world. So in the beginning, I would like to present a little bit more about our vision, our strategy, and what automation really needs. Standardization is one of the biggest topic. And we also learned trust building pilot projects is one big step, and also innovation and changes also in the organization is one big topic in this way to automate a mature fab. And then I will go to a short summary what we have done with our automation, and then Siegfried will follow with the continuous, I said continuous conclusion, because we have no conclusion. There is still forwarding the automation also in other 200 millimeter fabs. First question, do we need automation, vision and strategy before we start the first project? I would say yes, it's a really yes. Can we realize automation in a running, non-automated, an automation prepared manufacturing environment? Yes, this is also possible, but we need some things to do before this really can happen. In our case, our vision was in the direction of fully automation, was formulated in two slogans. It comes from our management, and it says in German was this, or I try to translate this here in English: nobody should touch a lot or a cassette anymore, and all lots are equal in regard to automation. And what does it mean in the translation into automation language? All transports between process tools and for all lots must be automated. And this slogan we used also every time or the whole time during our presentation. And oops, I hope you can see it. Yes. Okay. And then there is really a need. You need also a strategy how you can, where you can start with the automation. And the automation, we had a relatively good basic level in our fab. That means we had equipment integration, we had automation, wafer transport, and also RFID systems. And then afterwards, we looked also into the level one, which we said here, for the automation of all these lot, move in, move out, and also automation of on-time delivery. And later, then we go to the automation in the hardware side. So, and this strategy, we said, okay, where should we start? And one point was this diagram, which we used. On the x-axis, you see the throughput. We said low, medium, high, or on the other side, the epsilon or the y-axis is then the workflow complexity. And we start really on the right upper corner to start with the sorter processes, ashing processes, wet cleaners, which are relatively low complexity, but they had a high throughput. And so then we go in this direction, the implant, and then the other metrology tools, which have a higher complexity, but they have also a high throughput. In the second, we go in this direction on the upper side, where we look for lower complexity, but not so a high throughput. And in the end, then we start to go in the other areas of our manufacturing. But since this time, we learned also that the stability of the process itself is a very, very important part for collecting the right places where you can start. And there was also clear that we will find or come to a point where the ROI for automation is not anymore valid. So, but we don't know exactly what is the level where we can automate. In this starting point, that was a goal. We said 80%. Then we said, okay, what is also very important to bring the management also show, I call it here trust building project, pilot projects. And as I said before, we showed this in the sorter area. We take a very, very first solution in the ash area. Maybe some people also from Fabmatics can remember this really first application. And then with these applications, the Pharos, this ash application, and also the wet application, we can find trust from our, or get trust from our management to follow and work continuously in this automation direction. But automation needs also standardization, and standardization means also in the workflow side, the tool interfaces. As you know, there was no real standardized environment in the beginning, because all the systems are designed and built up for manual, for humans to work with the machines. And so we had to do a lot of work also to prepare this for our automation system. And also we came very soon to the problem that we saw that the automation hardware has also to be standardized. We cannot build every time a new complete system. So this was also the reason this prototype from the Hero Rail here, what you can see, which was in 2009 designed. But what I also said before, the mindset change. This is a very big topic. Automation approach in the 200 millimeter mature fab needs a strong preparation and analytic phase. You have to analytic the whole processes and flows and also in details before you really can start an automation project. And the mindset change is fundamental for all management and operation levels because it's a complete or it's another world when the automation is like in our case then really as a fully automated system. Automation influenced the whole organization. This was also not clear from the beginning that also not only the shop floor is influenced, but also the other organization, also the development and people in the offices. And for this, we need a guideline, we said, which is easy to understand and can be used by automation and tool experts together. And that's what comes up for us to say before we go really into automation in hardware, we make sure the general automation principles are understood and followed by all team members and also the managers. So there is also really a lot of work to do to bring these people, the person in this direction. And the principles here, what I would like to explain, we said, okay, the quality comes first. Strategy these days also for the automation. There is no discussion about this. We do automation for improvement of our KPIs, quality and productivity only. And we agree, and this said automation means shifting decisions making from human to system. This is really a topic which is not so easy to, yeah, to bring in, and but you have to bring this in because the people have to understand what is their job and what is their responsibility after the automation. And this is a very important sequence which we find out and say, at first you have to stabilize your processes, then you have to standardize, then you have to optimize. Some cases you can really optimize this before you automate. And benefits may already come from stabilization and standardization or optimization only. And in some cases also automation as a final hardware automation as a final step does not pay off. And therefore it is really done. And this is also very important to understand. Here you see some examples. Stability, I think one example here is really to make the whole process stable also for loading and unloading. We have done a lot of sensor analytics for the load ports because when humans are working there, they are accept more when the sensor is not working stable. But for a robotic system, you have to be in a stable mode. Standardization was also a big topic, especially here. One example, the test wafer handling, which was in the time before on the department side. And we bring this all together so that we have today a test wafer, a standardized handling and automated this. Optimization is really also a big topic. And here is one example, our wafer notch process. We analyze this process very deep and find out or find a lot of wafer notching processes which are not anymore necessary. So if you can eliminate this, then it's the best before you try to automate this. And then the automation part, really what I said before, experiment management system is necessary because then you can also do experiments in your fab from the people from the development, also from the office side Otherwise, yeah, there is no person who you can call and tell him what he has to do. So was also a very, very important step. And here the summary for our journey from the standardization to fully automation. The numbers which you can see here are now relatively actual. So we are running this here under full load. And as you see here, the goal was 80% minimum. We have now about 90 and 95% fully automated moves. And this is very impressive and also a big step forward in our fab. But the benefits are sometimes you can see later, but they're significant also when we start was mainly the improvement of the operator efficiency. But you have also a better tool usage because of the less variability. Tool stability is also better and reliability because of the predictability of the tool loading. And another point is also the epsilon Y, almost no wafer losses due to handling. Okay, in the beginning we had also some problems, but as the system is now running, there is not this problem anymore. And we can increase the load limit for several tools types, and that means then also a higher capacity without buying new machines. And a better manufacturing, especially like this was here in the Corona time when the staff shortage is, that is also not influencing anymore so deep your production. Yes, and now I come to the conclusion and would like to give up to Siegfried Ickert, because we see now in this year there are also a lot of new automation topics coming up, and also 200 millimeter manufacturing capacity demand increases dramatically, and for this you need also an automation for a profitable growth and delivery stability. And the hero concept was one of our key elements on our automation. So I would like now to give over to Siegfried.
Yeah, hello from my side as well. And unfortunately, I'm not allowed to tell you anything about the robotics doc from Fabmatics today, but I want to talk about the Hero Rail as well. And with the new generation, maybe we come a little bit closer to this idea of the robotics doc. So it's a pity, Harald, that you cannot be here. Because when I talk about the Hero Rail, I want to go back about 14 years into the past. And for you, the Hero Rail, maybe I place myself in front of the camera so you can see me. For you, the Hero Rail already, please get back with the slides. For you, the Hero Rail already was a result that turned up after all these intensive work you have done to get this level of fab automation, or to get a very detailed idea of what you want and how you want to automate. And for me, 11 years ago, the Hero was my first project I was working on. I'm still today, and hopefully will support this into the future as well. So when we talk about the Hero Rail, you can see the last system of the latest, maybe the latest system of the first generation on the left. And for Infineon, the Hero Rail was a small puzzle piece beside all the other mentioned things you have to take into consideration when you want to automate. But this puzzle piece was a very important one, because Harald already said it, it was kind of an enabler. And it was developed as a matching link between the transportation system on the one side, the RTD, so the dispatching system as well, and the tools, of course, all the other things. But of course, very focused on the situation at Infineon at this time. And here you can see on the left side this please go back one slide. I think we should, or we can have a longer look onto this beautiful system on the right side. Here's a little comparison of these both generations. So the first generation was from over the years, the demands for the system expanded, of course, and on this system we added just 8 additional buffers, so this is kind of crazy. If you see the small base system, I don't know what the future will bring for the new generation of on the right side, but I can tell you it is much more flexible and capable of, that you can do same things, but maybe you're not, it is not required. So creating a matching robot handling system for an automated tool loading in a 200mm fab is, especially for a new customer, normally takes us 1 to 3 years of all the things you have to do, so discussions, plannings, analysis, and so on. And I want to wrap this up on 2 slides for today, because there are 2 main questions for me. The one is, what is the ideal habitat or the ideal environment for the Hero Rail? And the other question is, when we look into the past, then we will see the future as well. So let me just go over to the next slide, please. The Hero Rail was implemented into a very ideal environment. The conditions were pretty good and the tasks were pretty easy. And the conditions at Infineon are still ideal because you have the open cassettes, so no box handling. The cassettes are served just in time, very close to the tools. The tools are very good aligned. The way is paved for the Hero. There's a lot of space. The operators got involved early, and we had a big and very motivated teams. So on the right side, the initial demands for the Hero were the high flexibility, and this is most important, the high flexibility of the robot and the gripper in the combination, because of the huge variety of tools and tool load ports situations, combinations, and so on. As well as the slim design, multiple and obvious safety features to soothe the operators. I will do you no harm, the Hero always was telling. And of course, a very simple and durable design. We never won a design award for this, but the variability of the system compensated for this, of course. Yeah. After 14 years and different design evolutions, to as well catch the higher hanging fruits or reap them, the time has come to extensively widen its field of operation or application. And please go over to the next slide, because there you can see how much the new generation increased. The area of this diagram shows you this change, and it's hard to tell. I even have to speed up a little bit, but the main functionality we changed because there is a new generation of robots, of controllers, of safety features, of logic behind this, and so on, that makes it possible that nearly all physical characteristics increased. And we are now talking about applications that are possible to handle with a reach of 1.5 meters, 20 kilogram payload and things like this. Charging on the fly as an example, and very important, the robot itself has an intrinsically safe movement. And besides the fact that this system And maybe you can go over to the next slide, I guess. Besides the fact that the system well deserved this mandatory upgrade of hardware and software, it is helpful for us and for you as a customer as well, and to get a bigger overlapping of these different automation systems for the tool loading. Because on the one hand, you have the stationary robot cells, you have the rail-guided systems, you have the freely driving systems, and the much overlapping you have, the much you have the chance to increase or to speed up the concept phase. And as well, you are able to do more and more specific, or to realize more and more specific challenges. And so I'm sure the hero will remain as a part of tomorrow, to use your slogan. And at this, with this last slide, maybe you can switch to this last slide. I just want to say thank you to you and to all the colleagues who worked on these projects with the Hero Rail. It was a pleasure and it was a very great time. So thanks a lot, Harald, and all the others.
Harold, we broke some ground today. Thank you for helping us put this together. Mr. Eckert, thank you so much for this great presentation put together. We hope you get feeling better soon, Harold. And
yes, no problem.
Come back with us. Are there any questions regarding the work that they're doing in automating this fab and have done so step by step, meticulously over the years?
Hello, Frank Heinlein from Infineon Dresden. I was always wondering, when looking at the heroes, why you don't give him a rucksack where he can put 2 lots more in his bag and do one run and put it on the load ports. Why is that so?
If I understood you correctly, you were wondering why there are no additional buffers normally. So
on the running robot, you know,
yeah,
it goes
yeah.
to the buffer,
So
it takes 3 lots,
yeah,
and then runs
yeah.
to the load ports.
There are a lot of systems who do have this. Normally 1 to 2 buffers on this system, but we saw in the real movement of this robot that the main topic is the time you need for the handling. So it's additional handling time for you if you take the lot and place it on the internal buffer. It is sometimes much faster if you just grab it out of the lift and bring it directly to the tool and place it on the load port. So you have to always calculate this and see what's necessary, what's a better solution. But the new generation is capable to have faster movements. And I think personally that there will be more systems in the future who have these buffers on the system. Yeah.
Okay. Any other questions?
Thank you.
For either Mr. Eckert or for Mr. Heinrich? Rico. Oh wait, we have a question way back in the corner. Stephanie, if you could take the mic to that gentleman.
Hi, Martin Vogt, AMS Osram. Why are you developing a rail system in the year 22 and not just trying AGV? What are your reasons for still sticking to a rail system?
I quite didn't understand what's the intention of the question.
There are free roaming AVGs on the market.
Okay.
And you have a rail system. And I just wanted to know, what are your reasons to still develop rail systems?
Yeah, the rail-guided system has can be built smaller. You have a defined way where it is going, so the operator knows where it goes and knows where he can go. So this is a very positive effect on the cooperation of the operator with the systems. And with the small systems, you are able to bring in, depending on the width of your AL, to bring in 2 systems in best case. So you have on the one side one system running, on the other side the other system, and in the middle you have still a path for the operator. If you have a freely driving system, you always have the same path for the operator and the system. And it's much faster as well, if you want to.
Okay. Any other question back there, or any place? Well, we had a technical challenge here today, and I think Catherine and you two gentlemen have totally solved it. Thank you so much. And we have a couple of gifts for you. Harold, even though you're not here, I promise
I will drink this for you.
that this wine will be taken care of, and I won't drink it. And we'll see that Catherine gets it to you later. Thank you so much, both of you. Let's
Thanks
give
a
them a
lot.
big hand.
Yeah.
Thank you very much. Bye.
Our final presentation today is a presentation by Alexander Grosser. He is manager of Silicon Foundry, Bosch Reitlingen, Germany, and Axel Wogawa, software engineer at Sistema. Their presentation is titled An Eclipse IoT Solution for In Situ Sensor Integration in a Wafer Fab. Let's have both these gentlemen come forward. And I'm not sure who's going to lead out, but I'll let whoever is do it. Thank you so much for joining us.
Thanks.
And your slide is there, and a pointer is there, and forward and backward on the slides.
Great, thank you.
Thank you so much for coming.
Thanks. So what an honor to be here with you, and I'm very proud to see so many guys dressed with nice shirts. So welcome, Bosch guys. Okay, so this is Axel, and we prepared something for you. I know it's late in the evening, and we want to stress you with a technical deep dive on IoT solution for in-situ sensor integration at this beautiful wafer fab in Reutlingen. So the ones who haven't been there, this is our fab building. It's looking as today, and if you want to come in a couple of years, it's will be looking different. So, okay. Otherwise, some of you may wonder, why is this foundry managing guy talking about IoT sensor integration? There's just 3 simple reasons for that. So one of them is I just like this stuff. Factory automation, IoT, that's my passion. On the other, the second one is our project manager, so Yvonne Bergman. She's presenting the same stuff right now at the Arrowhead Tools final symposium in Sweden today or yesterday. I'm not sure about this, but she can't make it here. And the third thing is, so this is based on a public funded project. It's called Arrowhead Tools. And 3-4 years ago, so I initiated this project for Bosch. And so it's kind of coming home and drawing what we saw a couple of years ago. Okay, what is Bosch? And about our founder, so he always gave a statement like this: we should all strive to improve the status quo. And of course, in our fab, we have a huge amount of sensors already integrated. We have a system, but we are still looking for something to doing better. And this is what we want to show today, is the approach, how we have done it and why we think it's better than things we have done before. Okay, so what we'll tell you about is short words, how we are. I mean, we could talk weeks about Bosch and about something, the use case, what drives us from a fab perspective to do sensor integration. And Axel will explain you in the details how this entire IoT solution works like and what are the benefits from our perspective and from data perspective about this solution, and a short outlook, and of course a huge acknowledgement to the team. Okay, Bosch. Just some figures, and I guess all of you just having at least 1 or 2 Bosch devices in your life. So just imagine if you turn your smartphone the next time, so the screen will adapt, and this is all triggered by a Bosch MEMS sensor. So just a rough overview. So last year, we had just a revenue of 78 billion euro with an EBIT of 3.2 billion euro, and all the ones with the nice white t-shirts here are part of these 403,000 people around the world. And we have 440 subsidiaries, and 2 of them are very close to this business, what we are talking here. So we have this new semiconductor fab just a kilometer north of here in Dresden. And we have the beautiful one here in Reutlingen, which is still growing. And this is separated in 2 buildings on 2 fabs. So we have the one which is dedicated to front end. And this is something what Thomas mentioned. So we have 150 and 200 millimeter. And the main business is, of course, in MEMS, still ASICs for automotive. And we spend efforts in R&D for SiC devices. And of course, in our back end, currently it is prepared for 150 millimeter, 200. And some of you may wonder why 300. Of course, we have a 300 millimeter fab in Dresden as well. And so these products can be measured in Dresden, and further production take place in Reutlingen. Okay, another partner of this project is a company, it's called Bosch I/O. And this is a company, it's an in-house company within Bosch, and they are located in Berlin. And what they do and what they offer, it's an in-house service for digitalization and artificial IoT stuff. And so what they do is they do consulting and they do installation, all these IoT stuff and digital projects within Bosch. So whenever a certain plant, one of these 440 devices, so on the R&D, have questions or needs or demands on this, so we have a kind of in-house consulting and in-house service for that. On the right side is a quite important thing for them and for her strategy. So the statement is, you have to think twice a little bit. If Bosch can do it, you can do it. So what is behind this? What is the meaning of this Bosch can do it, you can do it? All what they do and all her developments are based on open source. So they are very linked to this entire Eclipse Foundation, and everything they do, they develop with certain parts or with devices from this Eclipse IoT stuff. And so this is her strategy, this is her vision, and this is how we act. And this is what we implemented as a back end within this solution, because this back end was developed by Bosch I/O. So to the use case itself. I'm from the fab, and so I guess all of you are very familiar with this entire production process. And what is this about? So we're talking about this rectangular, which is a little bit yellow, so I try to give them the litho effect. And in this effect, especially the photoresist. And so we had issues here, or let's say issues, maybe it's a harder word, but what we want to do is we want to get machine data out of this special photoresist process, because this photoresist is a key quality indicator for the quality of the products. So where's the solution ongoing, which is regular, is we process the wafer, and later on this wafer will be measured, and we get a certain quality about the resist. And what we were looking for is a kind of in situ, it's an online information about this process, and the important parts are this, what is mentioned here. So it is flow rate. What's the flow rate of this resist? What's the volume which was dispensed? And there were bubbles in it. And to get the difficulty here is that each machine does have a different kind of resist, and this is hard to handle, these resists. So you could imagine, so the liquidiest one is like olive oil, and the hardest one to detect and even to process is like a little bit fluid honey also. So it's not that easy to handle it, and to get the precise information about the volume which was dispensed. And so what we developed, or probably mostly fabs do it this way, as we have extensive testing. All the lots get measured and tested afterwards, but there's one huge issue. There's a delay between the processing within the tool and the measuring afterwards. And even, these little tools have a high throughput, and from the time a certain thing happened in the tool and the processing is not as expected to the time when you detect it and you can act, you have an issue with a time delay, and you can, let's say, generate wafers that are other than you want to. And another one is, as I mentioned before, so we have a different kind of resist within the tools, and all these tools need maintenance and need bottle exchange. And we want to go from a predictive maintenance, so let's say change this bottle after certain hours, after a certain amount of wafer, whatever, to change these bottles or make a cleaning of the pipes or changing valves or whatever, depending from the quality of these dispensers. So to be more precise and preventive maintenance, so in an extended way, jump from preventive maintenance to predictive maintenance. And to get an impression how this dispense looks like, so there's on the video on the right side, it's just a wafer, and you drop these photoresist on it, and then by centrifugal forces, so the resist will be spread over the wafer. And in the middle you see the sensor. It's a clamp-on ultrasonic sensor, which provides the signal during this dispense process and even all the time online. And on the right side, it's kind of it's the signal after certain processing steps or data processing steps, how it looks like. And we have an integral, and we take the amount of the integral and take it as the number or the volume which was dispensed on the wafer. Okay, here I'm going to hand over to you.
Thanks, Alex. Yes, as we've just heard, the key idea to solving the task in that project was to install additional sensors at the equipment to measure the rate of liquid flowing through the pipes. But of course, it's not sufficient to only install sensors and that's it. But instead, you need a full stack IoT solution in order to extract the relevant information from the sensor measurements, and in the end, to improve the overall production process. And what does this IoT solution in that project comprise? At first, again, we install a couple of sensors at an existing equipment that measure the liquid flowing through the pipes. And along with these sensors, we install a small industry computer that we call IoT Gateway, and which I'm going to talk about a bit more in detail in a second. And this small industry computer, it connects the sensors to the IoT backend server. This is the place where the measurement data coming from all the IoT gateways is centrally stored and distributed to consumer systems. In this project, the main consumer system was an existing fault detection and classification system that it received the pre-processed data from the shop floor and then automatically detected or detects whether there are issues in the process. So again, that fault detection and classification system, it was already in place. It was part of the existing automation infrastructure, and we retrofitted the IoT solution consisting of the sensors, the IoT gateways, and the backend along with it. So one key idea in that project and in IoT in general is to interconnect all these components via open and interoperable standard protocols. So the I in IIoT or in IoT stands for internet, which clearly doesn't mean that you need to connect your shop floor to the internet, but instead you build solutions on top of the technology the internet is built upon, and use that technology, IP-based protocols, to interconnect all of these components as it suits. So zooming in a bit more, I'm going to tell you a bit more about that first component, the IoT gateway. Again, it is responsible for connecting to the sensors that were attached in the equipment, reading out the raw data from these sensors. They are communicating via a sensor-specific protocol called Modbus in that case. And the IoT gateway now translates that protocol into IP-based communication, and of course also processes that raw data stream to extract the relevant bits of information and forward that pre-processed data to the IT backend. And the second part of the application running on the IoT gateway is a so-called Arrowhead service discovery component that serves for the purpose of automatically connecting the IoT gateway at runtime to the backend by receiving connection data at runtime automatically. So again, I'm zooming in a bit further. What's happening in the IoT gateway in order to extract the relevant bits of information out of the raw sensor signal? So here I've plotted like a small amount of a time series of the signal coming from the sensors. This is liquid flow rate flowing through the pipes, so how much liquid per time is flowing through. And it's obvious that that signal includes a couple of challenges. First, it drifts over time. So even though no liquid is flowing through the pipes, the sensor signal eventually drifts back and forth, which is due to the measurement principle. And another challenge is the obvious random noise on top of that drift. And the only relevant part of the information in that signal is the one that I marked green here. So these like large peaks, they are when actually liquid is flowing through the pipes. And all the white area around that, nothing's happening actually at the equipment. So the task of the IoT gateway is now to process that data stream by a somewhat sophisticated data processing logic and filter out the relevant bits of information to detect when is actually a dispense action happening. And if so, how much liquid was being dispensed. So as that stream comes into the gateway emits a dispense event as soon as it detects one proper dispense peak, and all the rest of the time it remains silent. And by that, it tremendously reduces network load by just sending out the relevant bits of information. So the events emitted by the IoT gateway are arriving in the central IoT backend server. Again, this was in this project built by the project partner Bosch.io, and they leveraged a couple of components from the Eclipse IoT space. All of these components are free, open source, and they were used for several tasks like managing device configurations or configuration of the devices that we installed in the shop floor, connecting and forwarding data from the shop floor to the backend, modeling device capabilities, and also like modeling and constantly updating a digital twin of all the devices in the shop floor. And again, all of that software running in the IoT backend was built on free open source software. So now the data is available in that central IoT backend server and is ready to be distributed or consumed by backend systems. So in our case, again, the main consumer was a fault detection and classification system, which was already there in place before that project, and which now receives the dispense events and checks whether enough liquid was dispensed, or if not, triggers an action like manual inspection or similar. But since the data in the IoT backend is now openly available in that open source system, it's conceivable to have like multiple more consumers. Like for example, lithography engineers could at their workspace have a live overview of the processing data from the shop floor and monitor if everything in the process is working correctly, or maintenance staff members could observe the data and see or get notified if maintenance actions are about to be a good idea to perform. Or facility members could also trigger replacement of liquid bottles and so on and so on. So these are just examples of potential consumers of that data, which is, yeah, it's open and it's freely available due to our IoT approach. So.
You done? Thank you. Okay, what are the benefits from these solutions? So as I mentioned before, there's similar solutions available as before, but we considered these 4 main benefits. So first of all, we got what we were looking for. So the missing information on the process stability of the photoresist dispensing has become available for us. So this was our main objective from a fab operation perspective. Oh, you didn't.
Yes, yeah, I don't need it, yeah, thanks. Another advantage that I mentioned previously is by installing that IoT gateway close to the equipment and do the data pre-processing right at the equipment and only sending out the relevant bits of information onto the network, we tremendously reduced the network load. And yeah, again, we don't blow irrelevant data to all the databases and the network, but only the bits that are interesting for us. And clearly another advantage is for the IoT backend to be comprised of only open source components from the Eclipse IoT world, and thus that backend server is the complete opposite of a closed black box system, but instead you know what's going on there, it's understandable, it's the information, how it works, is open for everyone to look into, and the data is freely consumable by whatever consumer system.
Yes, and the third one, I mean, everybody who works on public funded project knows the ones who providing the money are very happy about this. So it is a prototype still, but we can, or at least we will, and we have plans for this, to install this on further production tools after ending the project. So it's really that easy to handle, and we got a wide acceptance within the factory automation team and within the operation of Litho, that they said we want to have the system. And it is not that expensive, and it's not that complicated to handle it. So there are a lot of people willing that we get the system and install it on further lithography tools in our fab. And that's a great success of such a project. Otherwise, it's jumping from a development phase to an operation phase. Okay, thank you and acknowledgement. So we got a huge acknowledgement from IEEE. So there's a paper out of it. It's not available yet, but it will become available, I guess, the next month. And so we got accepted from this Cyber-Physical Systems conference in May, which took place in Great Britain, and we were presenting it at this conference. And of course, we have to say thank you to Excel Joint Undertaking and all the sponsors of this. So it was part of the Area Tools project, and which is not a given. So it was the first time that we worked together in this combination, so with Bosch, Waferfab, Bosch, I/O, and Systema, and it's worked out very, very well. And yeah, and I want to say thank you as well to the Arrowhead project, especially this was part of the work package 9, and this was led by our friend Germa Schneider. So thank you, Germa. I don't know if you want to listen now, but thank you. And finally, that's all we had for you today. And the ones who don't know, so the building in the